For this isothermal compressor, the work per kilomole gas is given, as well as the values of the inlet and outlet densities or specific volumes. And we are asked to calculate the amount of heat that must be removed from that compressor in order to make this possible. So this is an example of a non-adiabatic compressor. According to our energy balance, since we know the amount of work, we only need to determine the change in enthalpy of the flowing streams in order to calculate the heat. So this seems like a quite innocent question. That is until you had a look at the shape of this Berthelot equation together with the expression that we need to evaluate for this change in enthalpy. And we can see that it would be impossible to determine that slope of the isobars on the volume temperature diagram. I really hope that you sweated with this for a bit on your own, because the easiest way to calculate this is to remember that we have our definition of convenience for enthalpy that still applies, and we can therefore express our change in enthalpy in terms of a change in internal energy. The change in internal energy for non-ideal gases requires us to differentiate pressure to temperature, which suits this Berthelot equation much better, and this is an equation that we can actually get answers from if we realize that this temperature is 350 Kelvin. This part of that expression can be evaluated in different ways. You can have this equation, or keep the pressure constant, change the volume. Now keep the volume constant, change the pressure, or first change the pressure at constant volume and now at pressure 2, change the volume.